Yes, thank you. So I'm very happy to be here to introduce SVOM and especially the results we obtained during these first 3 months of commissioning. So if you agree, and even if you disagree, I will present this today. So for those who are not very familiar with SVOM, I will just go through some reminders about the mission, the instruments and the science case, and I will try to show you a little bit of what we managed to do and especially what we managed to detect over this last 3 months of commissioning operation. And I will leave you with the one slide showing you the calendar for the next months we have also. So let's start with the SVOM mission. So this is a cartoon picture, of our satellite. So it looks like very similar to Swift. It's actually largely inspired by this mission. So we have actually on this satellite platform two main high energy gamma ray instruments. So one called Eclair, which is a coded mask that have real-time triggering capabilities, and especially a low energy threshold at 4 keV. So Eclair is going to detect sources from 4 keV to 120, 150 keV, and it will be able to localize sources within 12 arc minutes at maximum. And so we have also a second high energy instrument called GRM, Gamma Ray Burst Monitor, yes, that is also able to trigger in real-time sources from 15 keV to 5 MeV, but with a very rough localization of the source. Typically, the accuracy will be several degrees. So, well, we don't localize much. And besides these two instruments, so two high energy instruments, we have two follow-up instruments. So MXT called micro-channel X-ray telescope. So it's the same kind of optics than the Einstein probe WXT module. So it's lobsterized optics. So this X-ray telescope is going to detect sources from 0.2 to 10 keV and will be able to localize the source within 1 arc minute, typical accuracy. The field of view of MXT is 1 degree by 1 degree, which is quite interesting for an X-ray telescope to have such a large field of view. And finally, the last instrument on board is the visible telescope. So it's a 40 centimeter telescope with two channels, a blue channel. So we don't have standard filters. We have like a blue channel and a red channel that is operating from 600 nanometer to 1000, if I remember well. And so launch of SVOM was the 22nd of June this year for 3 nominal years, and we expect to extend the mission for 2 additional years then. So this is a real view of the instruments, well, a real view when it was in the integration hall in Shanghai in October 2023 before the launch. So you can see here Eclair, this is this size, well, this size. This is not that big. The overall payload here is less than 1 ton, so it's a small satellite actually. You have the visible telescope here, and you have here the GRM detectors. So actually we have 3 gamma ray detectors, so that we call GRD1, GRD2, GRD3. Well, actually I don't know if this one is 1, 2, or 3, but anyway, we have 3 of them. And you can see here the MXT telescope here. Okay, so once we have this satellite, we have to communicate in real time with it to get the alert in real time and be able to disseminate this alert to all of you through the GCN system. And so actually, under the path of our satellite, we have installed what we call VHF alert network, which are actually small radio antennas that are able to communicate in real time once the satellite is in the visibility of one of those antennas that are actually under the path of the satellite. So latitude plus 30 degrees and minus 30 degrees. And so actually we are able to downlink a few information from an alert. So typically position, light curves, the time of the trigger, etc. So this few information, key information, will be actually distributed to all of you through the GCN system in less than 30 seconds for 2/3 of these alerts. So this is the mission requirements, let's say. All those VHF packets, so coming from the satellite, are actually processed at the French Science Center with those guys in the room. And so in real time, they process these packets, produce the scientific products that will be then distributed to all the community. So this is real time, and so we have also path every several hours with big antennas, X-band data that are then here managed by the Chinese science center. So we have 2 science centers in SVOM, and the data are mirroring between the 2 science centers. So now we are able to communicate with the satellite, but we want to also coordinate multi-wavelength follow-up. So we have different types of partnership with ground-based telescopes. So we have official partners in red. I'm not sure I put all the different partners, but it's at least a subset of the partners we have already. We have also associate partners, which are people that are external to them, but are willing to really provide fast follow-up observation and be able to publish results with us if they want. And we are also thinking of the LC buying some time to the LC objective. What is interesting with SVOM is that the pointing strategy is really optimized to have ground-based and space synergies, because we made the pointing strategy of SVOM always at the opposite direction of the sun. And our idea was that we want to detect gamma burst, when the satellite is in the night side of the Earth, so that fast follow-up observation on the ground can be performed. So you won't have gamma burst close to the sun with SVOM, but you will still have some burst close to the moon. The moon we cannot release these constraints, but at least the sun we can. The bad points of this is that we have the Earth in our field of view more or less half of the time of the orbit, which is about an hour and a half. So we are also like Einstein probe in lower orbit at 30 degrees of inclination. So we are following the Einstein probe actually more or less on the same orbit. And so this is really important. This point, this typical pointing strategy, I think it's a new way of optimizing the ground-based and the space telescope synergies. Okay, the science programs for SVOM are the following. So of course, SVOM has been designed for gamma burst detections and gamma burst science. So this is largely inspired from SWIFT, from the SWIFT mission, of course. So we believe that we are going to spend 20% of our time on GRB detection and follow-up. So once a GRB is detected, we will spend typically 14 orbits one day following this burst with the MXT and VT telescope. And yes, of course, we have a satellite that is able to make autonomous slew, very rapid slew to the targets. So we are also really well designed for multi-messenger transient astronomy. And so we will perform gravitational wave follow-up, well, for the little overlap we have with the O4 run, if we are able to do this. Otherwise, it will be O5, but the localization will be maybe better. We don't know. 4 minutes, yes. And so we have also a kind of observatory program that for which people can post some proposal, and ATTAC will just review this proposal and give you the time you want it for this observation. So this is not target of opportunity program. This is more a classical observatory program. We believe that these fractions of these 3 different science programs will change over the time of the mission, and especially we think that we will make more TO later during the mission than what we are going to do right now, which will be typically 1 TO per day. Okay, I will be quicker just to give you some rough idea of why SVOM is interesting compared so some innovations we have compared to SWIFT, but not compared to Einstein probe. We have actually a 4 kV low energy threshold, and we see already with Einstein probe WXT that there is a new space of discoveries with such low energy threshold, discovering fast X-ray transients. Once we detect a burst, hopefully if GRM has also detected the burst in the same time, we will be able to have a full spectral coverage of the burst emission. So it's kind of merging SWIFT, BAT, and Fermi GBM spectral coverage in one single platform, so which is nice. We have an MXT X-ray telescope, which has a large field of view, 1 degree by 1 degree, so it's very interesting for especially for gravitational wave follow-up, for example, or neutrino follow-ups. Sensitive visible telescopes, and we have also a pointing strategy that is really optimized for ground-based telescope follow-up, because we will detect bursts when it's during night side and never close to this. Some pictures of the launch. So SVOM is flying, so you can recognize the YouTube bar here. So there are plenty of videos of the SVOM launch. So if you want to have this, or I can show you it later. But we are flying. This is not the Einstein probe launch. As you can see, the weather was not as sunny as during Einstein probe. So this is clearly just to not mistake people. Very quickly, so the first 3 months of SVOM commissioning. So this is the calendar we had after the launch of SVOM. So the launch was on June 22nd. So we started with 20 days of very preliminary phase called launch and early orbit phase. But this is when we switch on all the systems, the solar panels, the instrument controllers, the VHF communication system, etc., etc. And we are now in the commissioning phase where we try to understand the performance of the instruments, the performance of the trigger, the slew, etc. I will leave this slide for you later if you want to read it. This is a rough idea of what is the instrument status right now. I just wanted to mention this, that for the VHF network, we are actually, so I told you that the mission requirements was 36% of our alert should be delivered through the GCN system in less than 30 seconds with respect to the alert time. And actually, we are more close to 84%. So the VHF network is working very well for SVOM, actually. These are the positions in the sky map of all the triggers we got since the launch. So we had validated triggers. We have plenty of false things right now, but validated triggers, we have 71 triggers. So we can see that in the yellow, we have plenty of galactic trigger, non-GRBs triggers. This is because we spend a lot of time in the galactic plane for calibration purpose. So that's why we trigger a lot right now, but we won't trigger much on this galactic plane. This is not the idea of SVOM. We will mainly monitor the extragalactic part here. And so we have plenty of long gamma bursts, some short gamma bursts, and also some what we preliminarily classified as X-ray flash bursts. So we have few of them detected by Eclair. Since the launch, we have computed, yes, just finished in 1 minute. We have managed to send many GCNs circulars, actually. I think the SVOM community is already very active. So you can have some extract here, but I can send you the links. So 4 GRBs during the LEOP phase, and we have now 29 GRBs during the commissioning phase. These are some examples of light curves that we can put with the GRM instruments. So here and also here light curves from Eclair. So I don't have time to go into the details. I just leave you with this last slide to show you the calendar for the next months for us. So actually, I could not be here on Wednesday because we have an in-flight acceptance review in Toulouse this week. So this is an important milestone for the project. By the end of September, I hope that we will be able to have an automated slew enabled for MXT and VT regularly. Right now, the slew is not yet enabled automatically, except when we are doing some tests. I hope that we have Eclair GRM MXT VT calibration procedure ending. Early October, we should start the nominal science exploitation of SVOM. For you, this means that the science working group for gamma burst observatory science should start, and we should start to have collaborative work with you within the SVOM collaboration. So, and maybe most importantly for all of you, we are going to release GCN notices, but probably by November, December, because we need more time to better understand the trigger of Eclair. And GRM and the different false trigger we have right now. So we think that we still need the October months to get some statistics on this and better understand the trigger. So probably by the end of the year, we will be able to send publicly GCN notices through the GCN system. And by spring, we will release a special issue to just published performance instruments of the instruments, the alert reception and distribution system in performances and the first scientific results.